Welcome back to my darkroom. Today we're going to talk about something I mentioned in my last sensitometry video, and that is how to calibrate your sensitometer. Now, I have a couple of different kinds. The type that I've done or shown in older videos is made by Tobias. It's one of their Wedge X series sensitometers, and it's made for the dental industry, but it does use a halogen bulb. However, it's not really good for film, so I don't actually use that one. What I do have is a 3M model, which is also a halogen bulb, and I needed to calibrate it for my film speed test in order to get full film speed and be able to chart that correctly and so forth. However, 3M doesn't support this device anymore, and they have no way of telling me what the actual exposure is. So I have to figure that out. Now you can use the instructions, or kind of, not instructions, but follow along with my journey in order to calibrate your own. Even if you're using something like an enlarger as a sensitometer, that's perfectly fine. And remember, this is a sensitometer where you are exposing film to a step wedge, not the densitometer that reads them. The densitometer that I'm using for all of this is the Dektronics Printalizer densitometer, which has worked very, very well, and it's good for reading small samples. It's also, because it's a new device, doesn't have the possibility of drift and everything like that that my old x-rite might have, since x-rite doesn't support the densitometers anymore. So there's some information we can use to kind of get to where we need to be. However, I want to say what we're doing is calibrating with information in our hands, but a little bit of guesswork or assumptions. That is different than if you sent a machine to the manufacturer and they calibrated it with their very expensive tools to give you an exact exposure value that you can then use for your film work. Okay, now that's very, very different. If you are able to do that, great. That's what you want. You want them to be able to tell you exactly in millilux what the exposure is, and even better, millilux seconds. That's the combination of brightness and time. Okay? If you are unable to do that, and that's probably going to be every sensitometer out there, you're going to be unable to, then it's up to you to kind of figure that out. To do that, we do need to use a film of high quality that you can use to trust the manufacturer to actually have that film speed. In my case, I'm using Kodak T-Max 100. I trust that Kodak is going to really make a 100 speed film, and it's going to be consistent batch to batch. Ilford, I would probably trust like Delta 100. I think that would be a really good film to trust. But Ilford, even though they say they're using the ISO standards, but they also say that they don't use that sort of stuff, and they go by like what's visual to the eye through the printing process. I think they're probably still doing this stuff to get a true ISO. I wouldn't trust any second tier films. FOMA, Kentmere, stuff like that. But if you're using Acros 2, T-Max 100, and probably even Delta 100, I think you can do this with pretty good confidence that that is a 100 speed film. So now we need to get the sensitometer to actually read or produce a sample that reads as a 100 speed film. So with my machine, I have no idea what the light output is. I cannot read it with a light meter because it's not bright enough, but I do have a Calumet shutter tester. That's one of these devices right here. So I can at least read the exposure time. And for me, it's about exactly 1/6 of a second. So I can be armed with that information, but that really still doesn't quite give me anything to go on. So let's think through this. Thinking about the Kodak sensitometry workbook, they give us some information, and we can use that information to kind of figure out what we need to do. So when they're talking about exposure, they say that they have, in their example, a sensitometer light source that produces 100,000 millilux. And it has an exposure time of 1/5 of a second. They do the calculation, 1/5 of 100,000 is 20,000 millilux seconds. So they're using 20,000 millilux seconds. The log of that is 4.3. So 4.3 log units of exposure. They then go on to say that they put a filter of 0.95 density between the film or the step wedge and the light. There is no reason given for that. They just say that they use one, and that's the amount. And it reduces the lux output to, or the log output rather, to 3.35 log units of exposure. That's the important number for us. 3.35 log units of exposure. They gave us an example of that 100,000 and the 1/5 of a second because those are round, easy numbers to calculate. 100,000, a fifth of that, 20,000. Perfect. Easy to figure out when you're learning how to do it. The log of that does come out to 4.3, but that 0.95 filter amount is just, it's just to get down to the 3.35. That's it. If they started with a different exposure time or brightness, then they would have used a different filter amount to get to that 3.35. That's the number we need, and that's what we're going to work with. The next step. You need to know what your step wedge reads. Now they give two examples. They give an 11-step wedge and they give a 21-step wedge. They use the 11 throughout simply because it's faster to graph. You have fewer points to graph. I have a 21-step wedge, so I have a lot of points. But the values that they give for their step wedge are, again, very, very clean and very easy to calculate. So it is like 0.05, and then every step is 0.3 from that. Exactly, no deviation. Real step wedges are not going to be that perfect. That is theoretical, but it's not reality. So go ahead, read the densities of yours, write them down, and from there you can go on. When they do their film speed test, they are using patch number 3 or patch number 9, darkest 11, lightest 1. So patch number 9, third from darkest. And that has a value of 2.45 density units. That is the one that gives them 0.1 density above base fog at the 0.9 exposure units, which then when you do the whole film speed calculation, 800 divided by the anti-log of 0.9 gives them 100 film speed. That means we're looking for our patch that's also 2.45 density to give us that same amount of exposure. No, I don't have one. It's close. It's not exact. It's a little bit off. All right, so here we have the sensitometer. We've got our graph paper. And this chart right here, let's zoom in. This is what Kodak has, right? So this is their sample. And what we see is each exposure is exactly on the one stop. So down here, each spot exactly dead on. Perfect. Perfect. Which we're not going to get in real life. But we've got the 0.9 exposure right here, which is exactly 0.1 above base fog. So ideally, this is what we want. This is where we want ours to end up. Problem is, our numbers aren't going to be this perfect. So we're going to have to fudge it a little bit in order to get there. So to do that, what we're going to do is we're going to assume that the exposure coming out of this is 3.35 log units. Now I understand it may not actually be at this point, but we're going to make that assumption for moving forward. You need to read the densities of your step wedge. I'm using a Kodak step tablet number 2. All right, so what you're going to do is you're going to read your step wedge. So this is my wedge values right here. Okay, so darkest to lightest, and I have them numbered 21 through 1. Then you're going to subtract that from 3.35. Okay, so once you do that, then you have your wedge values. That's this set of numbers here. So I then wrote those down on another piece of paper so I don't have everything mixed up. So I've got my wedge values. All right, these values are going to be what make up the bottom row. All right, so what's important is number 5 is 0.86. This in Kodak sample would be 0.9, but mine isn't 0.9, it's 0.86. All right, and then number 6 is 1.0. So I'm actually not going to get step 5 exactly on 0.9. It's going to be just a little bit to the right. So for that, let's zoom in here again. So each one of these, and remember I'm using the Kodak E50 or E64 paper. So I've got 0.6, 0.7, 0.8, and then 0.9. So 0.82, A4, A6. So right here is where my step number 5 lands. And then step number 6 is on 1.0, which lands right here. What I need is for the delta of those 2 points to land at 0.29. Let's go ahead and mark that here. So there's 0.29. I need my line to land exactly or cross exactly this point here where 0.9 and 0.29 intersect. So how do we do that? Glad you asked. Go ahead and make an exposure. I'm just, like I said before, using T-Max 100. Make an exposure on your sensitometer. Load it up, develop the film. Once you do, you get something that looks like this. Okay? And you're going to read each of those patches and you're going to write those values down. That's what I have here. This was test 1, 2, 3, 4, 5, and so on. How many tests did you do, Greg? Oh, 1 or 2. Just a couple. I was having some problems. Anyway, once you get past that, and this is why I'm making this video, I don't want you to have to go through that many steps. Okay, what I actually come up with is this one. So you make an exposure, and we're only going to look at these. I'm not going to go through all the steps, or rather all the trial and error that I did. So what I have for a filter in my densitometer right now is, because it's a halogen bulb, I have a piece of 80A gel filter, all right, to make it daylight. Except it didn't make it fully daylight. It's pretty close. So I also have 80 or 80D, something like that. So much lighter. Both of these together make full daylight. Now you can read the densities of those if you need to. I didn't, because I knew they had to be in here to make this daylight regardless. So the way that they go in the sensitometer, this plate has a bunch of these screws. You lift it off. There is underneath this, there's a piece of white plexi, and under that is another piece of white plexi. So it's just sandwiched between them. There's a little screw that holds the bottom one tight against the top plate here. So it's just sandwiched in between. From there, I made a test. And by test I mean I exposed a piece of film and developed it. And you want to develop it to that same average gradient that we went through in the film development or film speed video for the sensitometry series. That's going to make sure you're at the right spot. So develop that, and again, you get one of these, you read the steps, and I wrote down the values for each step. I start at the darkest and I work my way down to the lightest. These are your vertical axis. So the wedge is your X horizontal axis. By wedge I mean the values of this subtracted from 3.35. And then the actual readings of my film sample are the vertical y-axis. And you come up with a chart. I'm actually going to draw it on here so that you can see how it compares to Kodak. Actually, you know what? Let's not. Let's put that on a fresh piece of paper so you can see what that looked like. So what we have with just the light balancing filters over in my sensitometer is what we're going to graph. We're only going to do up to about step 8 because we don't need the whole graph. Now, of course, you do the whole graph in order to make sure you have the right development time, but that's already been solved in this case. So give me a moment. We're going to chart this. All right, so that's enough for what we need. We got the beginning of our straight line. So here's the important intersection, and it's right here, right? Because I've got my 0.29 above base fog marked. I just need to see where it intersects. Where it intersects happens to be right there. That is exactly on the 0.8 density line. 0.8, I need to be at 0.9. Now that makes it easy for me because I need to shift this over 0.1. And I'm going to do that by adding 0.1 neutral density to my stack under here. So I have to open this up, separate the two pieces of plexi where my light balancing filters are, and then put another piece of filter in there. Now, you can get neutral density that low. I'm looking for mine. So this is what I ended up getting. 0.1. It's very light. This is 1/3 of a stop. Remember, a stop is 0.3. So that's it right here, 0.1. Now, what took me all those tests was I didn't have this. And I was trying to use other things to try to get that 0.1. And it didn't work. So I could have made this much, much easier if I just hadn't been lazy and not try to have to buy this and use what I had on hand. I didn't. A lot of trial and error, a lot of frustration, but this is all that I needed to get. So, lesson learned on my part. So, took this, put it inside the machine, right under this piece of plexi here, and re-exposed a new strip, read those values, and let's chart that, and you can see the difference. Well, actually, I will say, before I did that, I used this strip. This is 0.15, not 0.1, 0.15. Let me show you where this went first. All right, so here we have the 0.15 neutral density. Where do we intersect? Right here. 0.15. So we get that refocus. So with this being the 0.1 or 0.8, 0.9, 0.9 and a half, because here's 1, 9. So that 0.15 shifted it 0.15. We went half of a third of a stop too far. Okay, so we take that out of the sensitometer, replace it with this guy, and let's see where that goes. All right, now, yes, it's getting crowded, but what we just had was the intersection of 0.29 exactly on the 0.9 mark. Okay, precisely there. Why? Because 0.1 from the 0.8 mark is 0.9, and I added, ta-da, 0.1 density. So the more we add, the more we shift our point that way. And of course, if we subtract, we'll shift it the other way. This would be very difficult if this wasn't bright enough to begin with. Fortunately, it is. So by using a piece of trusted 100 speed film and getting this shifted exactly left and right until I got that 0.9 exposure point to be exactly 0.1 above base fog, I now trust that this is calibrated precisely to a 3.35 exposure, which is where we want to be. If I needed to shift this over, I could. Now, when I use a 400 speed film like Tri-X, then my speed point would be shifted over to the 0.3 mark. If I use something like Pan F, it would be shifted to the 1.2 mark, and so on. So make sure it's filtered for daylight. That's how we're going to make sure we have the right color light, because even panchromatic black and white is meant for daylight. And from there, it's a matter of just assume 3.35 when you subtract your step wedge densities. Then when you plot, your speed point is going to move left and right depending on how you add or subtract neutral density. And then just add it in those specific increments. Theater gels, they work okay. They're not going to be precise. In my case, that 0.15, it did read 0.15, but it is a theater lighting gel. But you're going to get more precise with something like a true neutral density filter. They're easily available on the eBay market. That's where I bought mine, and they don't have to be all that expensive. But depending on how much filtration you need to use, you might add quite a bit. And then depending on your device, you might be able to subtract that filtration to use slower films. In my case, I could subtract and get the speed point. Well, by subtract, what I mean is if I just leave the filtration as is and I expose a piece of 400 speed film, that speed point is going to be over the 0.3 mark. That's great, except there's not enough graph to the left of that to get a good idea of the full toe. So generally you would filter a little bit, maybe 2 stops, precisely 2 stops, to move the speed point over from the 0.3 mark to the 0.9 mark so you can see the whole toe. You may not need to, depends on the graph paper you have. In my case, the graph paper I'm using would require that. But it doesn't have to. If you're using standard graph paper, you just mark further to the left and you'll be fine. You're going to have 0 and then you're going to have negative numbers to the left. Nothing wrong with that. That's exactly what Kodak does when they graph things like 3200 T-Max. They just have negative numbers to the left. This paper just doesn't allow for it, and that's just the paper that I choose to use. You don't have to do that. For me, if I wanted to move that speed point over just for pure graphing purposes, I would add 2 stops of filtration for a 400 speed film, and it'd be just fine. But as is, if I leave everything the same, and I plot a 100 speed, and then I expose a 400 speed, I would have 2 graphs running parallel to one another, or 2 lines running parallel to each other, 2 stops apart. And that's exactly what I want to see. I would get that relative difference shown on the graph. So that's how I calibrated You just need to get that speed point, 100 speed film, trusted 100 speed. And bear in mind, that's what I'm doing. I'm making that assumption that Kodak is correct. T-Max 100 is in fact 100. And from there, you should be good to go. You can get pretty darn close. Is it going to be exact? Is it going to be perfect? Is it going to be ISO standard? No, you need to have that fully, truly calibrated by the manufacturer. Just good luck finding one that will do that. Until somebody makes a sensitometer. And I don't see Highland jumping on that. I think Dektronics is looking at it. Derek and I have talked about it a little bit on my Discord about what it would take, but nothing super serious. Just kind of spitballing what a sensitometer includes. So don't expect any new machines out there, but if you want to get one, especially a halogen one, this is how I would recommend trying to calibrate it for good film speed testing. All right, that's going to do it. It's kind of a long explanation showing some graphs, but really that's all it comes down to. I have been asked, before we leave, can you do this if you're using like a spot meter as a densitometer? I don't think so. You might be able to, but I don't think so. And that's because a spot meter, you are reading relative densities. You're not necessarily reading true lux exposure readings. So being able to get those true precise densities, probably not. You're going to have to use a densitometer. Fortunately, Derek's Dektronic Printolyzer, or was it the Dektronic? Dektronic Printolyzer brain. His new densitometer is more affordable, new, and supported. So if you're thinking of doing anything like this, grab one of those. They're great. They are repeatably reliable, and you get both the reflection and transmission densitometer all in one. So I'm really glad he sent that to me so I could see how it works, because I'm starting to trust my x-rite less and less. So sorry for a little bit of a ramble. I realize this isn't for everyone, but for those of you who are trying to get a sensitometer calibrated for some of this film speed stuff, or whatever your purposes are, then hopefully this will get you in that right direction. Do you need, however, to do this to make good photographs? Absolutely not. You don't need any of this to make good, interesting photographs. This is just going to help you understand your materials in a deep scientific way, and that itself may help you just understand how you're making a good photograph. All right, thanks for watching. I appreciate your help in supporting this channel, either through the membership tab or down below in the super thanks, or any sort of merchandise sales. Those do help me get all the film for test like this to help you guys. And we'll see you next time.